Let's try a few more limits. This time we're going to use the shortcut straight away. The limit as x goes to infinity of 5x cubed plus x plus 1 over x squared minus 1. And this is the limit as x goes to minus infinity of the leading term in the numerator divided by the leading term in the denominator. And now I can cancel, and I get that it's the limit as x goes to negative infinity of 5x, and this of course is equal to negative infinity. Now we can look at the limit as x goes to infinity of 5x plus 1 over x squared minus 4 using the same trick. We have that that's the limit as x goes to infinity of the leading term in the numerator divided by the leading term in the denominator, and that is the limit as x goes to infinity of 5 over x, cancelling one of those x's, and as x goes to infinity, 5 times 1 over x goes to 0, so that limit is 0. And for this one, the limit as x goes to negative infinity of the same function, 5x plus 1 over x squared minus 4, is the limit as x goes to negative infinity of 5x over x squared. And again, cancelling one of those x's, it's the limit as x goes to negative infinity of 5 over x. And this is negative, but it's also going to 0, because as the x increases in absolute value, 1 over x tends to 0, so this limit is 0. So this function, f of x equals 5x plus 1 over x squared minus 4, has one horizontal asymptote at x equals 0, and you can see that it has two vertical asymptotes. The denominator factors as x minus 2 by x plus 2, and neither of those factors divide the numerator, so it's got two vertical asymptotes, one at x equals 2 and one at x equals minus 2. Now this function has an absolute value in it, and we must remember that the absolute value of x is equal to x if x is greater than 0, and it's equal to negative x if x is less than or equal to 0. So since we're calculating the limit as x approaches negative infinity, the x's we're considering are eventually all negative. So this is equal to the limit as x approaches negative infinity of 5x to the 5 plus 1, and we can replace the absolute value by negative x for negative values of x. So this is negative x to the 5 minus 4. Remember here, x itself is negative, so negative x is positive, and negative x is the absolute value of x. So now we can limit our attention to the leading terms. This is the limit as x tends to minus infinity of 5x to the 5 over negative 1 to the 5 is negative 1 times x to the 5. And this is, I can pull out that negative 5 times the limit as x goes to negative infinity, cancelling the x's I get 1, so the answer is negative 5.